Hello everyone, this is Shruti Saxena Das. In this video, we are going to discuss about insertion in single linked list. And insertion in a single linked list can be done in three ways. We can insert in the beginning, we can insert at the end. So insert at beginning, insert at end, and insert in middle. These are the three options. In this particular video, we are going to discuss the first one, that is insert in the beginning. So if you, in case you are having a linked list and you want to insert at the beginning, in the start of the linked list, then how do we do so? So we'll discuss the code also in C, and first of all we'll discuss the method how to insert a particular node in the beginning of a linked list. So linked list, suppose we are having a linked list in which three elements are there, 10, 20, 30. So your linked list is of this type. It is storing 10, 20, 30. So in the introduction of linked list video lecture, we have already discussed that we are going to use a pointer variable head that will point to the first node. As it is a pointer, it must be storing an address. So it is storing the address of the first node. Okay, this is a variable, pointer variable. Now this is the first node, it is holding 10, and in the next field it is storing the address of this particular node. The second node is containing 20 in the data field, and in the next field it is storing the address of this node. Now this 30 node, as this one is the last node, so it is containing null in the last field, in the next field. Now in case we want to insert a new element or a new node whose value is 40 and we want to insert it in the beginning. Okay, so for this insertion, what do we need? The first thing is we need to create a memory for this particular node. So to create a memory through pointers at runtime, we need malloc function. Malloc is a function which stands for memory allocation, and this particular, if you're using this function, you need to use a stdlib.h header file. You need to include that header file in your program. So what are we going to do? You have created a structure. I'll write it down. So this structure I have already explained in previous video in the introduction of linked list. So I'll write the structure. This will be the structure. Okay, in case if you are using type def, you can write in the separate line also, or if you want you can write like this also. Okay, so I'm going to write n wherever I want to use struct node. Now how will I allocate memory? In case I want to allocate memory through malloc function, so first of all I need to create a pointer of struct node type. As I'm using an alternative name using type def, I've given an alternative name as n, so I'll write n. N means a struct node, so I'm taking a pointer p. Okay, now this p, to allocate memory to this particular node, what I'm going to do, p is equals to, you need to write what is the syntax of malloc. You need to do typecasting. So here the data type is n, which is a struct node, so I'll write this is the typecasting, malloc size of n. So this is the method to allocate a memory to a node. When you'll write this particular statement, what is happening? This p is a pointer which is pointing to a memory location which is of n type. N means struct node type. Struct node type means it must be having two things. First field will be data, the second field will be next. So I'm going to create this node. Now I can create a node using this particular statement. Now here we are discussing if the new node I have to insert at the beginning, then see what I have to do. Already this linked list is present. Header must be pointing to this node. Now if I want to insert this node, the first thing is the next field of this node should point to this one. Okay, because this is going to become the first node, so this 10 node, the node which is containing 10 as the data, should become second node. So that's why this particular node should contain an address of this node. Okay, the second thing which we need to do is head should point to this new node, because this will become the first node. So head should not point to this, instead of this it should point to this newly created node. So we need to create these two links. Now how to create these two links? We'll start writing the function. So I'll write the function void insert at beginning. Okay, what do I need? I need to take one variable p, which will point to the newly created node. The second thing, I need to insert data. Data I'll ask from the user, whatever value he'll give, that we'll insert. Okay, now the next thing is I'll assign memory allocation to this newly created node by using malloc function. So I'll write the same statement which I have written above. So after writing this statement, see, now from this line one node is created. Okay, as I'm using malloc and p is pointing to this newly created node, that means p must be pointing to this newly created node. And as the data type I have given as n means a struct node, and in a struct node we have specified we are having two fields, data and next field. So from this line this has been done. So I have to give something in data and something in next. So how will I give? I'll ask from the user enter some value to be inserted. Enter value to be inserted. Scanf. So I'm going to read that value, as the value I'm taking is of integer data type. That's why I'm using %d. Ampersand I'll use, address of operator, and the variable name is data. So here one more thing is there. I cannot write data because data is a normal variable. I need to take p data. Okay, if you are using pointer to access any particular field, you need to use arrow operator for that. So here instead of writing data, I need to write p data, p arrow data. So if in case you are using pointer to access any of the field, you need to use arrow operator. If I want to access data, I need to write p arrow data. If I need to access next field, I need to write p arrow next. Okay, so what I'm going to do, scanf %d, as I'm going to read some integer value. Which integer value I want to read? P data. Okay, whatever value user is giving, that will be stored in p data. If you will give only data, so it is going to create as from this particular statement normal integer variable we are creating. Okay, so but when you'll write when you're writing like this, the element will be stored in data field. Okay, or one more thing is there, that if in case we are writing p data, as we have taken data type as n, in which already int data has been written. Here you can see int data has been written, so there is no need to take a new variable over here also. There is no need. We can directly write p data, and the data field, whatever, suppose user is giving 40, so 40 will be read here and it will directly be stored in p of data. That means here 40 will be stored. Okay, so after this, don't take this int data, we don't need it. Okay, so we have already taken data. Now see, there are two situations. The first situation says that whatever element you are going to insert is the first element. Okay, the second situation is whatever we have discussed here, that already there are some existing nodes and you are going to create a new node and you are going to insert it at the beginning. So there are two cases. So we'll take both the cases in our code, that if head is null. In the previous video, in introduction to linked list, I already told that we are going to take one variable head, and initially we'll we'll take it as global variable and we'll initialize it to null. Okay, null will signify that your linked list is initially empty. So if head is null, that means if there is no node in the linked list, then in that case whatever we are going to insert will be the first node. So this is going to be the first node. We have already taken p data. Now in the next node, because this is the first and the last node, if head is null means your linked list is empty. So whatever node you are going to insert will be the first node. Okay, first and only node. So that's why we have already given some data in this particular field. In next field we'll give null, because this is the only node. So that's why we have given data, and in the next field I'll give null. So what I'm going to write in p next, I'll give null. Okay, now we have given null. This node is created, this node is full, but the only thing is that we need to modify the value of head. Initially head was null, which was signifying that your linked list was empty, but now we have inserted one node and your linked list is not empty. That means head should now point to this particular node. So how can we do so? We'll simply write head equals to p. Okay, this is p. P means p is a pointer variable which is storing the address of this node. Now the same address will be stored in head also. Okay, so this will be done if head is null. Else, in case your linked list is not empty and it is having nodes, like this situation which we discussed, in this case this is p, this newly created node is p. Now we have already given some data in this, 40 is given, but what we have to do in p next, what should come? To create this link, you can see that this particular node address is stored in head. So here what we can do, we need address of the first node. First node means this particular node. So address of this particular node is already stored in head. So we can write p next equals to head. Okay, head is storing the address. Suppose this particular node is stored at 1000. So this head must be 1000. Okay, this head must be storing the address of this particular node. So what we can do, we can write p next equals to head. Okay, so p next will become 1000. So it will automatically point to this node. Okay, so that's what we are going to do here, that if head is not null, in that case what we'll do, p next will be equals to head. It will point to the first node. And second thing, you can see that here we need to create this link also. So to create this link, what we can write, head equals to p. Okay, this is particular node. See, when you use pointers use addresses. Okay, so we can directly write like this, head equals to p means, suppose this particular p node is stored at 2000. Now head, instead of pointing to 1000, it should point to 2000. Okay, so we'll write it over here, head equals to p. So this will be the complete code for insertion at the beginning. So I hope this must be clear. To insert at the beginning, so finally your linked list will be like this. First node will be 40, head must be pointing to this, instead of this link will be destroyed, and this will be like this. So 40, 10, 20, 30, your linked list will be like this. So I hope you must have understood. In case of any confusion, you can write your queries in comment section. Thank you so much.